All right, this is 3.0. I'm going to go ahead and do the launch task because this is so short. So without a calculator, we're filling in the table. So 2 cubed is 8, 2 squared is 4, and so on. This should be a real quick review from Algebra 2 and actually Algebra 1. So I have this horizontal asymptote. And then this shows exponential growth. Then what's a nice connection to Unit 2 is the limit notation. The limit as x approaches negative infinity of f of x, that's approaching 0 on the left side of the graph. And on the right side, it's in fact shooting up to positive infinity. All right. I'd encourage you to pause the video and fill in the table on your own. And then when you have it, press play. So I'm filling in what I got from my calculator. So the domain for all exponential functions is negative infinity to infinity. The range starts with 0 to infinity, but if I shift the graph up or down or I reflect over the x-axis, that will impact my range. The horizontal asymptote is impacted by a shift up and down. All right, so I'm just going to guesstimate those values. Again, it's exponential growth, and then I have the exact same limit notation for the end behavior. Okay, so an exponential function is a continuous function with a variable in the exponent. This function can be used to model growth and decay of data. The general form or intercept form of an exponential function is y equals a times b to the x, where a is the initial value, b is the base. So you can see exponential growth is when a is positive and b is greater than 1. Decay, a is positive and b is a number between 0 and 1. What's interesting is exponential functions are always increasing or always decreasing. So that's interesting. All right, then example A. It says selected values of g of x are in the table, where g of x is a times b to the x. Use the given data to write two equations that can be used to find the values for the constants a and b. So I'm going to play the what do I know game. If g of x is a times b to the x, then I'm going to use this first value. So the g of x is 21.54 and the x value is 3. Then I'm going to use the second value, and for each equation, I can divide by the b cubed. Then what you're going to do is you're going to set 21.54 over b cubed equal to 3.62 over b to the 8th. You cross multiply, and when you solve that, b is 0.7. And then go plug that in here, and I got a was 62.8. All right, then this board work, this is really, really quite simple. If I want to describe the end behavior, as I go to the left, it's shooting to infinity. As I move to the right, the function is approaching the horizontal asymptote, y equals 0. All right, then on this one, as I move to the left, the function is approaching a height of 0. And as I move to the right, the function shoots down to negative infinity. All right, now in letter C, you really want to connect this back to this piece right here. The b value is 4, which is greater than 1. So this means I have exponential growth. So then as I move left, the end behavior is approaching 0. And as I move to the right, the end behavior is approaching positive infinity. All right, that's all there is to it.